Hello mathematicians, thank you for joining me today as we try to find, well, if we have V is the span of the set of vectors given by 1, 1, 2, 1, 1, 1, and 0, 1, 1, we'll want to find an orthonormal basis for this vector space using the Grahm-Schmidt Orthonormalization process. Alright, so the goal of the Grahm-Schmidt Orthonormalization process is to take the vectors that are given to me and turn them into a basis which is orthogonal, and each one is a unit vector. So where we start with is we say, okay, well, if we have v sub 1, I want to start off and say, well, can I turn that into a unit vector? So I'm going to find w sub 1 is going to be my first unit vector in my orthonormal basis. It's just going to be v sub 1 divided by the norm of v sub 1, so that we have a norm 1 unit vector. And so what we want is we just want 1, 1, 2 divided by the norm of that vector. Now in this case we're working in our cube, so we're going to use the usual dot product as the inner product. So to find the norm, I'm going to take the square root of the dot product of this with itself. That is, this is going to be the square root of 1 squared plus 1 squared plus 2 squared. So what I end up with is the vector 1, 1, 2 divided by its norm is 1 plus 1 plus 4 is 6. So over the square root of 6. And so then if I write that out, I'm going to get 1 divided by the square root of 6. 1 divided by the square root of 6. 2 divided by the square root of 6. So therefore I have a unit vector in the direction of v1. So by starting off with these vectors, I now have my first vector, which is a unit vector in the same direction as this. Now for the next part of the process, what we want to do is we want to find a vector which is orthogonal to w1, but has the remainder amount in the direction of vector 2. So what we're going to do is we're going to define our vector u2 as v2 minus the amount of v2 that is in the direction of w1. So that is, we're going to subtract off the projection of v2 onto w1. Alright, so what we're going to get here is 1, 1, 1 minus, and then the projection of v2 onto w1 is going to be, well, in general it's going to be the inner product of v2 with w1 divided by the inner product of w1 with itself times w1. Now in this case we know that the inner product of w1 with itself is just going to be 1 because this is unit vector, so it will simplify some of our work. So then the next step is, well, I'm going to take 1, 1, 1 minus, now if I take the inner product of v2 with w1, remember that's the inner product of 1, 1, 1 with 1 over the square root of 6, 1 over the square root of 6, 2 over the square root of 6. And then we're going to multiply by the vector w1, which is 1 over the square root of 6, 1 over the square root of 6, 2 over the square root of 6. Now again, remember that the norm here was 1, therefore the inner product of w1 with itself is just 1. So I'm not going to bother doing that. I'm just going to say, okay, divided by 1 keeps it the same. Then I'm left with 1, 1, 1 minus, and if I take this inner product, I get 1 times 1/6. So 1 over the square root of 6 plus 1 times 1 over the square root of 6 plus 2 over the square root of 6 multiplied by the vector 1 over the square root of 6, 1 over the square root of 6, 2 over the square root of 6. So now if we continue with this, we're just going to get 1, 1, 1 minus, and now here I have 1, 1, and 2 is 4 over the square root of 6 times 1 over the square root of 6, 1 over the square root of 6, 2 over the square root of 6. And so I'm left with 1, 1, 1 minus, now if I multiply these through, I get 4 over 6, 4 over 6, and 8 over 6. So now the last thing I need to do is just subtract those. Since I'm running out of room, I'm going to pull that back up here, and I'm going to say that this is going to be equal to Well, 1 minus 4/6, which is 2/3. 1 minus 2/3 is 1/3. Again, 1 minus 2/3 is 1/3. And now this is 1 minus 4/3 is going to be negative 1/3. Therefore, the vector which subtracts off the portion or finds an orthogonal vector which takes V2 and subtracts off the portion in the direction of W1 is just going to be 1/3, 1/3, negative 1/3. Now that we found the portion of V2 which is in the direction orthogonal to W1, what we need to do is we need to turn that into a unit vector. So that is, I'm going to take the U2 that I found and I'm going to divide by the norm of U2 so I can get a vector in the same direction, which is a unit vector. So therefore I'm going to take 1/3, 1/3, negative 1/3 and divide by its norm. So that's just going to be 1/3 squared plus 1/3 squared plus negative 1/3 squared, and then take the square root. So what I get is, well, 1/3 or 1/9 plus 1/9 plus 1/9 is indeed 1/3. So we get that the norm is just the square root of 1/3. Then dividing by the square root of 1/3 is the same as multiplying by the square root of 3. So we get that W2, or the unit vector, in a direction which is orthogonal to this one, is just going to be the square root of 3 over the 3, comma square root of 3 over 3, comma negative square root of 3 over 3. Alright, now that we've found our first two unit vectors, W1 and W2, we want to try to find our third unit vector, W3. Before we do that though, we're going to find U3, which is going to be the vector in the direction of V3, which is orthogonal to W1 and W2. So if I want to find the portion of V3 in that is orthogonal to those, what I'm going to do is take V3 and subtract off the portion of V3 in the direction of W1, that is the projection of V3 onto W1, and I'm going to subtract off the portion in the direction of W2, so I'm going to subtract off the projection of V3 onto W2. Now we've done this a couple of times. So what we're going to get is, well, V3 is just 0, 1, 1, and then I'm going to subtract off the inner product of that with W1 multiplied by W1, and then subtract off the inner product of our vector 0, 1, 1 with W2 multiplied by W2. So if we continue with this, we're going to get 0, 1, 1 minus. Now the inner product of these two is I would multiply the components, so 0 times 1 over the square root of 6 is 0. I get 1 over the square root of 6 plus 2 over the square root of 6 is 3 over the square root of 6 multiplied by 1 over the square root of 6, 1 over the square root of 6, 2 over the square root of 6. And then I'm going to subtract off this portion, and if I look at this, I get 0 times root 3 over 3 is 0. Root 3 over 3 minus root 3 over 3 is 0. So I'm going to get 0 times this vector is just going to be the 0 vector. And so now what I would do is to find U3 is I would finish this. So I would take 0, 1, 1 minus, well, 3 times 1 over root 6 is going to be 3 over 6, 3 over 6, 6 over 6. So I would get 0 over 3 over 6. 3 over 6 is 1/2. So I would get negative 1/2. 1 minus 1/2 is 1/2. And 1 minus 6 over 6 is 1. So I get negative 1/2, 1/2, 0. Therefore, the portion of V3, which is orthogonal to W1 and W2, is going to be negative 1/2, 1/2, 0. All right, so now that I found my U3, I just need to find my W3. That is, I need to turn that into a unit vector. So I'm going to take U3 divided by the norm of U3. So I have the vector negative 1/2, 1/2, 0. If I divide by the norm of that, that is just going to be negative 1/2 squared is 1/4 plus 1/4 is 1/2. So I get the square root of 1/2 as the norm. Then dividing by the square root of 1/2 is the same as multiplying by the square root of 2. So what I end up with is negative root 2 over 2, root 2 over 2, 0. Therefore, what we've found using the Grahm-Schmidt Orthonormalization process is that we started off with V was the span of this set of vectors. So we had a generating set of vectors. We found each time a unit vector in this direction, and then we found, well, we'll subtract off all our previous directions to get an orthogonal vector. Then we'll turn it into a unit vector by dividing by the norm. And by continuing their process, what we realize is that the basis of the span of this set, which is our vector space V, is given by these three vectors, and these three vectors will all be unit vectors, and they'll be orthogonal to each other. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.